Starting on number 12, there is there are two graphs that you should know. Let's do the parent function of sine, 1, -1. We talked about this in class before, but just to bring it back up here, we've got this is sine of x. And sine of x starts at here, goes up, down, up. And this happens at pi over 2. This happens at pi. This at 3 pi over 2. And this at 2 pi. For cosine of x, let me just draw them, then I'll talk about them. Okay, a couple of things to note here about each of these parent functions. Notice what they do. So this is the positive version of sine x over here. And for this, it usually starts here at 0, and it goes up to start. So it goes up, and it usually starts here at 0. With cosine, it usually starts here at 1 and goes down. And it might be helpful too to go ahead, just while we're doing it, let's go ahead and draw negative sign. So let's say I flip sine of x with a negative, 1, -1, pi over 2, pi, 3 pi over 2, and 2 pi. So say I flip it, I would start here in the middle and go down. It's a little hard to draw, not an artist here. Boom, down, up, down. So it's the same thing between these two graphs, except for it's flipped. Something similar what happens at cosine. So negative cosine of x would be 1, -1, pi over 2, pi. And sorry I'm taking a long time on this. I just want to be very thorough with the explanation of this, because noticing these features of the parent functions make this make a lot more sense. So draw my blue line here. Okay. And just one more thing to notice about the original parent functions, the negative sine and positive, the positive sine of x and the positive cosine of x. Notice the first max at x equals pi over 2. So my first max, I'll highlight this in green. Oh, why did I write 2? Pi over 2. That happens right here. That first max is there. And the first max for cosine happens at 0. First. These are just different things that can help us solve some of these problems, including 12 on, even through the free response. So let's look at this. We have the graph of a function here. And which of the following could be an expression for g of x? So a couple things I'm going to look at. What do they have in common here? Well, they have the 4's in common and the 2's in common, the negative 1's, except for this guy at the end is negative. That's important to note. So they all have the same period, and they all have the same shift of 1. So, and notice, this guy tells me, okay, well, if I start here, and I've got a positive sine function, so I start at x equals 0, because my c value is 0. So I start at x equals 0, And wherever I'm at on my graph, I start here. The sine function, because it's positive right here, should be going up. Like if I trace my graph up here, the parent function goes up first from my starting point. So, but here I'm going down to start with. So it can't be this answer. B, it tells me to start. That's what that phase shift, that's how I like to think about it when I'm solving these. Start at x equals pi over 2. So if I go to pi over 2, same thing here. I've got a positive sine function, like the positive a value. So right here, once again, I know on the parent function, sine should go up, but this goes down first. Or, sorry, from here, I should be looking at here. And from pi over 2, it's also going down, even though I should be going up. Can't be this one. And now we switch to cosine. So this tells me to start. X equals pi over 4. So I'm going to do that in purple. And notice with cosine, this is why it's important to have all my parent functions. So really, all of these parent functions up here are something I would be able to draw from memory. Because I can look at this and say, well, if I start at pi over 4 here, my function is going up from pi over 4, my starting point. But we know for a positive cosine, I go down first. So it can't be this one. And by process of elimination, obviously it's D, but let's look at it to kind of drive this concept home. So let's start at x equals 3 pi over 4. So let's start there. Okay. And now I've got a negative cosine. So I'm going to look at the negative cosine parent function. Really cosine's still the parent function, but like looking at this graph is what I mean. But if I look here, I start down and go up first. Oh, well, what do I do from 3 pi over 4? I start down and go up. You can see the symmetry here. Okay, I'm going up first for my starting point. 13. In Seattle, the number of daylight hours is dependent on the day of the year, and it gives me the function, t is 1, based on this model. Which of the following statements is correct? And each of these is asking about a max and min. So really, you need two things to answer this. I need my amplitude. And to get my amplitude, obviously, I need my midline. So if I remember that, my amplitude is this guy right here. And my midline is this guy right here. So if I just draw my midline, a max will be, so this is at 11.7. My amplitude goes up and down by that same amount. So I'm going to go up by 4.1. So add those together, that gives me 15.8. And if I go down by 4.1 with my amplitude, I would end up at math here. Math. I'm struggling. Give me 1 sec. Bad. It's been a long day. There we go, 7.6. So my max would be here. My min would be here. And that tells me it is B. And remember, this, and these, just to clarify, this is talking about my starting point. My starting point. And because this is sine, we know I don't start at a max. Your first max on sine happens at pi over 2. So it wouldn't be at my starting point here. 14. A game uses a large spinner of radius 15 feet that rotates at a constant rate to determine whether which prizes contestants win. using the figure above, it shows a representation here. Point P is at the wheel in the start position in the figure at time t equals 8 seconds. 4 rotations have been completed. So, I mean, that just tells me so 8 seconds, 4 rotations. I can divide that and get 2 seconds. Like just basically chop off the 8/4 and get 2 seconds per rotation, which is my period. Anyways, and P is in the same position as it was in time 0, and that's another point that tells me that that's period. The sinusoidal function is used to model the x-coordinate at the position of P as a function of time in t seconds, which of the following is appropriate. So if 2 is my period, make sure to go in DAB order. You go in DAB order. Because there's no C value on any of these. I just need DAB. I don't need C. So DAB is my midline. Well, my midline would go through the middle of the circle. Just be 0. That's why there's no D value at the end on any of these. The amplitude is from the midline to the top, which is 15. Then my B value is 2 pi over my period. So that's 2 pi over 2, which is pi. And that gives me C. Now this one is one that you're going to do in your calculator. So let me see here. Let me pull this up on my desktop so I don't have to flip back and forth to get the values here. So the way I know this is a calculator problem is it says to do my sinusoidal regression, and it's given here. So if you go to your calculator, let's do this together. And I go to Stat, Edit. Here, let me clear my calculator really quick. 2nd plus 712 should clear it. Apps, nope, sorry. Stat, Edit. Let's enter my list. So my T values are going to be my first list. 1, 3, 4, 7, 9, 11. Go for the next list. 29.1, 42.3, 50.6, 80.4, 76.8, and 46.9. Okay, just entering those. And now I go back into Stat, Calculate. And once ooh. That's not good. This version does not have that. So, you would do the same steps on your calculator though, and there should be a button. So let me quickly edit this on my calculator instead. Let me add these into my calculator here. So you would do the same steps and put it just L1 and L2. So 1, 3, 4, 7, 9, 11. You might have to wait to use one of the school calculators. For some reason, these do not have the sign regressions on them, like the app does not. 88.4, 76.8, 46.9. So same steps though. You go down to Stat Calc and you scroll down to Sign Reg. And go down to Calculate. And it gives you all of the values, okay? So let's go back here. and it gives you the order to put everything in, as right here. So I'm going to write that as y equals 29.515 sine. These are all the values that your calculator will give you. Parentheses 0.531 x plus negative 2.301. And I could rewrite this as minus if I wanted to, instead of plus and negative. Plus 58.583. Okay, I'm just rounded to 3 decimal places here. And it wants to know when t is 6. Okay, t is 6. So in this case, this is the same thing as my t. This is the same thing as my t. I can just plug in 6 into x here. So I would just have parentheses 6 and type this into my calculator. Make sure you are in radian mode. Make sure you were in radian mode. Make sure you are in radian mode. You go to mode. I can show you that on the calculator. Just to remind you there, you go to mode and make sure you're in radians. I am. So let me type this in. 29.515 sine 0.531 times 6 minus 2.301 plus 58.583. This gives you approximately, see,